Hi everyone. Today we're going to be talking about how to factor some quadratic trinomials when a equals 1. So these are some of the first types of quadratic expressions that you are usually exposed to, where you have x squared plus a number x plus some other number without a variable, and we are asked to put that into factored forms. That factored form looks something like a plus b, a plus b. We'll get into the specifics of that a little bit in a second, but one of the first things that I wanted to point out is that, first, especially when you get to test prep and other types of problems, we first need to understand how to recognize when we use this. So we end up using factoring in order to help us solve for these types of expressions or equations when we see them. One of the key things to look out for is that exponent. This only really applies to quadratics, which means that your highest power is going to be to the power of 2, or basically the leading variable is going to have or is going to be squared, basically. You can see it in all sorts of formats. Sometimes it might look something like this, where it's going to be a trinomial. Sometimes it will be equal to 0. If there is an equal sign, it always needs to be equal to 0. So in another video, we'll talk a little bit about what we do if there's another number on the other side of that equal sign. But we want to look out for that variable squared. Look for a squared equal to 0 if there is an equal sign, or something of that like. So when I say a is equal to 1, in this case, what I'm referring to is the very first variable here, that same one that I talked about being squared. Because when we look at one of these quadratic expressions, this is in the standard format, where it is ax squared plus bx plus c. This is an important formula or format that you'll need to remember for later and harder problems, so make sure to keep that in mind. So in this case, my a is 1, because remember that when we write a number in front of a variable, this is multiplication. So I could say that this is 1 times x squared, and then plus 8 times x, and then plus 7. So because it's just 1 times the x squared, we usually just leave that out. But you should always know that it's there when we don't write it. So because 1 is in front of the x squared, then 1 has to be a. Because 8 is in front of our x, that means 8 is our b. And because 7 doesn't have an x, that means 7 is equal to c. So this method only works for us when a is equal to 1. It's one of the simplest methods, but keep in mind that if the problem is more complicated, this method does not always work. So when a is equal to 1, we can follow these simple steps. First thing we want to do is look at c here. So c here is 7. We want to get the factors of this number. This is pretty easy because the only numbers that can multiply to get 7 is 1 times 7. For step 2, we want to make sure that the combination of these factors can add or subtract in order to give us the b, the number in the middle. So for this, that's going to be 1 plus 7 to equal 8. So once I figure that out, once I satisfy those two conditions, I can then just write my factors out. There's always going to be the squared variable, so we're going to put an x in each of these boxes, and then because it was a positive 1 and a positive 7, I'm going to write plus 1 in the first and plus 7 in the second. Now, for this, order doesn't matter. All that matters is that we satisfy those conditions. So it has to be factors of the last number without the variable, and then those factors need to add up in order to get the number in the middle. If that's the case, then we can just take those same factors here and drop them into these parentheses. So these are our factors, x plus 1 and then x plus 7. Some problems might ask you to go a little bit further and actually solve. So if you're ever asked to solve for a particular factor, all that means is that we're going to equal each of them to 0. Now, you might see that when it's just a simple factor like this, there's no like number before the x or anything like that. It's usually pretty easy because this always means it's going to be the opposite of whatever we had in our factored form. So in this case, you can subtract these on both sides. That gives me x equals -1 and then x equals -7. So these are the actual solutions to the problems, but the factors, if we were just asked for factors, it would be these things in the parentheses. And then, like I said, the solutions here are on the bottom. So let's go to a slightly harder problem where we have just a slightly bigger number. So in this case, we have the number -24. Now we switch things up a little bit because it's not all positive. So I start the same way. I want to find all the factors of this 24. The negative sign does not matter, and you're not going to put that into consideration when we are trying to decide our factors. All we want to know is what are the possible factors of 24. So right now, we can do 1 times 24. We can do 2 times 12. And you might notice that I'm going in order, 1 times, 2 times, 3 times, and so on, because this is the easiest way to make sure that you're not forgetting any sorts of numbers. If you jump all over and just try to think of whatever comes to mind first, sometimes that can lead to forgetting some of your factors here. So again, at 3, we have 3 times 8, 4 times 6, and then 5 can't work, and we then already have a 6 here. So the beauty of doing it this way is that we not only get all of our factors, but then we can definitely tell when we're done, because the moment that we start repeating numbers, that means that we've already tried everything that's possible. So I have 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. I want to figure out a combination that's going to give me a positive 2. So like I said before, we can add or subtract them, so they don't always have to be positive. In this case, it looks like the only possible way in order to get a positive 2 in the middle is going to be to have a positive 6. So we're going to have k plus 6, and then we're going to have to subtract that 4, k minus 4. This, of course, will mean that our solutions are -6 and then also a positive 4. In another video, I talked about foiling these. So remember that we can always distribute in order to, or basically go backwards in order to check our work. So if I do k times k, that gives me k squared. Do k times -4, that gives me -4k. Then I can do 6 times k, that's positive 6k. And then 6 times -4 is -24. These two in the middle need to be combined, which of course gives us that k squared plus 2k minus 24. Let's try one more example where we have a bigger number. And this will be the last example for this particular video. So here we have p squared minus 13p plus 40. So again, I want to find my factors of this. So I have 1 times 40, can do 2 times 20. 3 is not going to work. We could do 4 times 10. We can do 5. Let's see, 5 times 4 would be 20, so this has to be 5 times 8. 6 does not work evenly, 7 does not work evenly, and then that gets us back to 8, which we already have written down. So again, if we want a combination that is going to make 13 or negative 13 in this case, now that means probably either I'm going to need a much bigger number that's a negative, or both of my numbers are going to be negative. In this case, it's going to be the 5 and the 8. So we're going to have p minus 5 and then p minus 8. So those are our factors, p minus 5 and then p minus 8. And then, of course, our solutions would be p equals 5 as well as p equals 8. So that's all the basics of how we do basic factoring. Again, this is only for when a is equal to 1. So there will be another video where I talk about what do we do when we have a bigger number in front of our squared variable, or other ways to solve for these quadratic expressions when one of these methods does not work. So stay tuned for that and give this a try.